In its elemental form, hydrogen is the most abundant chemical substance in the universe. At standard temperature and pressure, it is a highly flammable, colorless, odorless, and tasteless gas with the molecular formula H2. It is non-toxic and very light, up to 14 times lighter than air, so it evaporates quickly and can rarely be found on Earth in its elemental form. Mostly, it chemically bonds in water and in organic compounds. We are facing a climate crisis and therefore urgently need changes in energy production and consumption. We are looking for more efficient and environmentally friendly technologies in transport, industry, energy, and households. We need to reduce consumption or make better use of resources such as fossil fuels, natural gas, biomass, and solar, wind, nuclear, and hydro energy. In the development of green and advanced alternative technologies, hydrogen, with its properties as an energy carrier, represents both a great opportunity and a challenge. In the widespread use of hydrogen and the exploitation of its great energy and economic potential, as well as the development of hydrogen technologies, the main challenges are the cleanliness and cost of the production processes and the storage and transport of hydrogen. If we want to produce hydrogen from existing natural sources, we have to split them. In the process, other gases, such as carbon dioxide, form, so we need to purify it. This makes the process energy-consuming and the efficiency low. The hydrogen obtained in this way can otherwise be stored and transported in liquid and gaseous form by ship or pipeline, like natural gas. A much cleaner process for obtaining hydrogen is electrolysis, in which the water molecule splits into oxygen and hydrogen. This hydrogen is very pure, but it is a costly process, just like hydrogen production from renewable sources such as wind and solar energy. If we want to use hydrogen as a fuel in the form of electricity in vehicles, we have to recombine it with oxygen. This chemical process can take place in a hydrogen fuel cell, where the two gases, oxygen and hydrogen, react. The advantage of a hydrogen fuel cell is that it converts most of the chemical energy into electricity. But at the same time, a major disadvantage is the high cost of the catalyst, usually platinum or nickel, which is the main accelerator of the reaction between the two gases to produce electricity. In the development of hydrogen technologies, there is also a major challenge in the storage and transportation of hydrogen, which is difficult to liquefy. Stored in gaseous form under high pressure, it poses a relative explosion risk, but one that does not exist when used properly. Hydrogen fuel cell vehicles, where the hydrogen is produced from renewable energy sources, would produce few harmful emissions to the environment. The whole society, consumers, scientists, educational institutions, policymakers, and the business community can all contribute to the development of hydrogen fuel cell technology, which is one of the promising environmentally and human-friendly green alternatives.